Hello, algebra classes. Let's take a look at 10.5 samples. This is the lesson where we learn how to make a box and whiskers plot, a data display that helps us see the variability in our data, and we also learned how to interpret a box and whiskers plot. Sample 1A asks us to make a box and whiskers plot of the data that we're given and to include and label the 5 data points used to create your plot. Show your work. So here's what we're given. T-shirt prices. So we went to a store and found out the prices perhaps of t-shirts that were on a rack, and I've already listed them in order from smallest to biggest, so you won't have to carry out that task. It's already done for you. The cheapest t-shirt was $5, the most expensive was $95, and we have all sorts of prices in between. First step is to figure out what the median, the lower quartile, and the upper quartile are of this data. Because there are 11 pieces of data, we can go ahead and find out the lower 5 pieces of data and box them up, and the upper 5 pieces of data, leaving the median in the middle. Remember, the boxes will touch if you have an even number of pieces of data. The boxes will not touch. There will be one number in the middle of the boxes. That will be your median if there is an odd number of values that you're given for data. All right, so our median is 42. And then our lower and upper quartiles will be the number in the middle of each of those boxes. And again, because we happen to have an odd number of values in our boxes, there's no further work other than to identify the number exactly in the middle of both of those boxes. So we have 2 data values in the box above our lower quartile, 2 data values below our lower quartile. Same thing in our upper box. We'll have 2 values above our upper quartile and 2 values below our upper quartile in the box. All right, we've identified everything we need now to create our box and whiskers plot. So the first thing we'll do in creating that box and whiskers plot is we will draw a number line, decide what values we would like to include evenly spaced on our number line. Since our smallest value is 5 and our largest is 95, I've chosen to go by tens from 0 to 100. That will accommodate all of my data. All right, so I'm going to pull off my lowest value, 5. The lower whisker will start at 5, and then it will proceed to the right, and the bottom of our box, and our box and whiskers plot will be 28. That's our lower quartile. The middle of our box will be 42. That's the median. And the top of our box will be 50. That's our upper quartile. And then our largest data value is 95. So we'll have a very long whisker spreading out to 95. So this just shows us the variability of our data, shows us what the middle 50% of our data looks like. From 28 to 50 is the middle 50% of our data. And then here is the lower fourth of our data. This is the upper fourth of our data. 1/4 plus 1/2 plus 1/4 gives us 1 whole. So that accounts for all of our data. All right, make sure that you do label your lowest data value, your highest data value, the lower quartile, the upper quartile, and the median on your box and whiskers plot. We're giving meaning to the data. All right, sample 1B asks us to calculate the IQR, that's the interquartile range, and to show our work for how we got that value. What we're trying to figure out is how far spread out is the middle 50% of the data. That's the box from 28 to 50. How many spaces is it? To figure out how far it is from 28 to 50, we find the difference of those 2 values. We'll take the bigger minus the smaller value to end up with the positive number 22. So our interquartile range is 22 units long. To get from 28 to 50, you would have to travel 22 units. Now we're going to use that interquartile range to identify any outliers if there are any, and to show our work. I've actually shown more work than is really technically necessary here. Using our visual sense here, we can notice that there might be an outlier up here. 95 might be an outlier because look how long this whisker is. It is certainly longer than the box. In order for this 95 to be an outlier, if it in fact is, it would have to be the interquartile range times 1.5, and then it would have to be that many spaces above 50. So we're going to say, well, let's go ahead and try out and see, is 95 an outlier? There could be outliers, there could be no outliers. Again, we'll check it out and see. It doesn't look like this would be possibly an outlier because this whisker isn't anywhere close to being 1.5 times the length of the interquartile range. But we're going to check out both just to make sure. All right, so first of all, is 95 greater than the upper quartile plus the interquartile range, 22 times 1.5? In other words, is this 95 more than 1.5 times the distance of the quartile above the upper quartile, 50? So again, to figure out for if this number up here is an outlier, we're going to start with that number and ask the question. So we'll need a question mark over a greater than sign. Take the upper quartile plus the interquartile range that we just figured out in sample 1b times 1.5. Okay, simplifying that, 22 times 1.5 is 33. So we ask, is 95 greater than 50 plus 33? And finally, simplifying that is 95, our possible outlier here, greater than 88. Yeah, that's true. That means that 95 is an outlier. It is more than 1.5 times the interquartile range above the upper quartile. Okay, now let's check and see if 5 is. We can see visually 5 is not going to be an outlier because that whisker is certainly not longer than that or much longer than that box range here. But let's just check it out and make sure. Is 5, this possible outlier down here, less than this time because we're below the quartile. Over here we were above the quartile, that's why it was greater than. So is 5 less than because we're below the lower quartile. Is it less than 28, the lower quartile, minus the interquartile range times 1.5? We're subtracting it because we're seeing how far below is it. So is 5 less than 28 minus 33? That's 22 times 1.5. Is 5 less than negative 5? Well, no, 5 is greater than any negative number, so it can't be less than a negative number. So that's false. So 5 is not an outlier. We did happen to find one outlier. Again, there's not necessarily any outliers. This determines that we do have one outlier, which is 95, because it is more than 1.5 times above the upper quartiles. It's more than 1.5 times the interquartile range above the upper quartile. Okay, so that completes our samples for this lesson. It's now time for you to move on to your quiz for this lesson, and make sure you're patterning your work on the quiz the same as you see in your guided practice homework and samples. And we'll see you next time.